But today we move into the third type of compound, which includes what are called polyatomic ions. Now, if you break down the name polyatomic ion, an ion is something that has a positive or negative charge. The suffix IC in English just makes this word an adjective, which is describing the noun of ions. If you think of the difference between romance and romantic, that's the only thing I can think of at the moment. Romance is the noun and romantic is an adjective. So generally in English, if you have an English test and you see words that end with ick, it's generally an adjective. And so atom, of course, we know what that means, and poly means many. So it's an adjective that describes ions that are made of many atoms. And here's the bad news. There's only one way to learn them, and that is through memorization. And I will tell you that I absolutely hate memorizing because I don't consider that learning. I think that it's just, I don't know, kind of pointless. But there's some instances where it just can't be helped, and there's no way to actually learn the idea behind why these things are named this way, or why they have the formula that they do. It's just, I guess, how it is. And so this is a list which basically describes the polyatomic ions. You don't have to remember this entire list. And that's what I was doing when you guys signed in. I was starting to put together the list of the ones that you do have to know, but I'm actually trying to organize them according to, I kind of put them in families so that they're a bit easier to remember. Now, I don't know what kind of tools you guys use when you have to memorize things, like whether it's definitions or anything like that. I like flashcards. And so what I usually do is I make a flashcard. Hold on, let me share a different screen and I'll show you what I mean. And that. Okay, so what I usually like to do is, like I said, I make flashcards. So if you get note cards or even just like pieces of paper or something like this. So obviously I can't draw very well. This is the front, this is the back. Because when I say that memorizing is the only way to learn, it really is. And it's going to be, at least for this part of the unit in chemistry, kind of an important thing to be able to recognize when a polyatomic ion is applied or not. And I'll explain the tricks that you can use to figure that out. So, for example, on the front, you would have a formula like this. So the formula includes the entire ion and its charge. Remember, it's polyatomic. That's why each one has more than one atom in it. And it has to have a charge. Now the charge range from +1 to -1, -2, or -3. And like I said, I don't know, depending on how you guys like to memorize things, I usually like to put them in groups of things that are kind of related. So what the book does, I'll go back to here. What the book does, and the PDF that I shared on Google Classroom for this, it's on page, what page is it on? 214. Whoa. Just calm down. What the heck? Okay. How the book organizes it by charge. So you can see that there's only 2 ions that have a positive charge. You don't even have to remember you don't have to remember dimercury. The only one you have to remember that's positive is ammonium. I don't know why it keeps highlighting the whole table, but anyway. So you have to remember that the formula NH4 represents ammonium, but you also have to remember that ammonium has a charge of +1. So between today and all of next week, we're just going to be practicing on writing formulas and naming things based on these formulas. So the book groups it according to charge. So all of the ions that have a -1 charge are here, -2 and -3. But I want to show you how I do it. But going back, before I show you how I group them together, going back to flashcards, if you want to use them. So for example, if I take the formula NO3, which has a charge of -1, on the back, I would write the name of that ion, which is nitrate. And so that way you can like quiz yourself to help to memorize these. Now, what I was in the middle of doing is trying to organize them. I didn't get it all the way done, so I'll just kind of finish writing out the groups as we go and explaining why they are this way. So far I have 3 sets of polyatomic ions, and they're grouped basically, I grouped them according to what element is in the ion besides oxygen and hydrogen. So for this group, okay, you don't want to, I guess I started too high. Oops. I'll do it down here then. I call this the chlorine group because it all contains chlorine. And we basically have the same charge for each one. They're all -1, so that makes it easy. And they just go by increasing amount of oxygen. So it turns out in Latin, which is what a lot of science vocabulary is based on, when you have the suffix ite or ate, that's an indication of a relative amount of oxygen. So the suffix ite indicates that there's less oxygen than the one that ends with ate. Now the problem is, for the chlorine group, you actually have 4 ions. So chlorite and chlorate are the 2 in the middle. And then you have ClO minus, which has even less oxygen than chlorite. So we add the prefix hypo, which is basically even less than. So this means less than. This is less than, and adding hypo means even less than that. Then you've got chlorate, 8 means more than. But because ClO4 has even more oxygen than chlorate, we add the prefix per, which is short for hyper. I guess we are too lazy to say hyperchlorate, but we just shorten it to perchlorate. So per is even more. And so the names reflect a relationship between the amount of oxygen. So that's the chlorine group. So what you'd have to remember is, like I said, the name and the formula. So if I can try to erase this without erasing everything. Boom, boom, boom. So if I ask you, what's the formula for chlorate? You would say ClO3, Lipnung, -1. So that's the chlorine group. Then I come over here. Oh, I can't expand. All right, never mind. This is the sulfur group. And I want you to compare the left side with the right side. So on the left side, we start with sulfite, which is SO3 -2. And kind of the partner to that is sulfate, which is SO4 -2. Notice that they have the same charge, but ite has a little bit less oxygen than 8. Here's where I add to that group, that family. When we add a hydrogen, so if you remember, oh goodness, do I still have it in here? I think so. Not my schedule. Nope. Where is it? Here we go. If you remember oh, sorry, that's from 10B. The periodic table, let me erase all this, make it nice and neat again. Okay. I think it was last week when I talked about how to determine the charge. So we said group 1 is +1, group 2 is +2, right? Hydrogen is in group 1. So hydrogen has a charge of +1. If I take hydrogen, which has a charge of +1, and I add it to SO3, which has a charge of -2, if I add up these charges, I get HSO3, but now the charge is reduced to -1. So that's what you see here with bisulfite. There's two names when you add hydrogen. You can either call it bisulfite or you can say hydrogen sulfite. It's totally up to you. They're both acceptable. And the same thing happens with sulfate. When you add hydrogen, the charge increases by 1 because we're going from -2 to -1. That's an increase of +1. That's the sulfur group. And the last one I was working on before you guys logged on was the phosphorus group. So I'll change to blue. And I can take a screenshot of these and send it to you in the line group so you can have them to study. So again, we start at the top with what I call the parent ion. That's the one that doesn't have any hydrogen on the front of it. And again, we've got phosphite, which has PO3, but now our starting charge is -3. And then we have phosphate, which is PO4, -3. So the same charge, but phosphate has one more oxygen than phosphite. I don't want you to try to make a shortcut that anything that ends with ITE has O3 and ATE is O4, because that is not true for all of the groups. You see chlorite here is NO2 and chlorate is, NO2, ClO2, and chlorate is ClO3. So that's not always applicable. There's going to be other ones that end with ITE and ATE that are not 3 and 4 as well. So like I said, as much as it sucks and as much as I hate it, and I wish that there was some other way, but in the however many hundreds of years we've been studying polyatomic ions, no one, at least that I've found so far, has thought of any kind of trick to be able to learn these except memorization, which is, like I said, awful because you're not actually learning it, it's just remembering it. Okay, so same thing when we add a hydrogen. Hydrogen by itself is +1. So when we add a hydrogen to phosphite, we get biphosphite or hydrogen phosphite, but our charge increases by 1. Same thing with biphosphate or hydrogen phosphate. The charge increases by 1. But here's the difference. With phosphite and phosphate, with the phosphorus group, because I can want to label them. With the phosphorus group, we're starting with a charge of 3. So we can then add another hydrogen to end up with a charge of -1. And this one we call di-2, dihydrogen phosphite and dihydrogen phosphate. Okay. All right. What do I want to make the next group? Let me get the list up so make sure I don't forget everything. All right, the next groups that I'll talk about are smaller. These are the biggest ones, by the way. The phosphorus group has the most ions in it. If you're more comfortable learning them by charge, then please learn them by charge. I find it easier for myself to learn them in groups where they have a common element because the name kind of repeats itself, like phosphite, biphosphite, dihydrogen phosphite, phosphate, biphosphate, dihydrogen phosphate. Boy, why is that? Okay, weird. I don't know why I stopped sharing. No, I don't want to do that either. That random windows popping up. Oh, because I'm in full screen, that's why. All right. Okay, the next one I will call the nitrogen group. There's only 2 in here. We've got NO2 minus, which is nitrite, and NO3 minus, which is nitrate. And that's it. Super simple. They're both -1. The O2 is ITE and the O3 is ATE. So NO2, NO3. So this answers the question one of you guys last week mention nitrate, I think. And I was like, no, 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 we haven't done that yet. And so now you see the difference. So there's a big difference, since I'm here anyway, just to mention, especially, I mean, we're not actually speaking to each other in class. So what I would normally do when I'm teaching you about the binary ionic compounds, when we talk about nitrogen being an ion, and the name of this is nitride. Normally, I would emphasize the D and say nitride, right? Because it comes straight from the element nitrogen when it's an ion. And there's a big difference between that and nitrite, which is NO2 minus. So it's important to distinguish between those two. So last week, when somebody used nitrate, I was like, nope, 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 because that's a totally different formula. All right, what color should I go with next? So how about purple? Okay. What is next? Let me look at the list to see what I've got. Aha. All right. Then the next one I'm going to call the, can't write with an eraser, Renee. Okay, purple. Boom. The next one, the chromium group. And so we've got CrO4 minus 2. That's called chromate. And interestingly enough, there is no chromite. Don't really know why, but. And Cr2O7, 2 minus, same charge, is called dichromate. Okay, and those are those two. Have I done green? I haven't done green. Next group is also only 2. I'm going to call this the carbon group. We've got CO3, which is minus 2. This is carbonate. And we've got HCO3. And again, when you add one hydrogen, you can write it 2 ways. You can say bicarbonate or hydrogen carbonate. Again, totally up to you, whichever one you like to use. Oh, wait. Line on the inside. Consistency is important. Blah, blah. Okay. What do we have left? I did those. That doesn't really belong to a group. Did all those. Okay, I think I only have the stragglers left over, which, and by that I mean the ones that don't really have a group. Just making sure I'm looking at the list. Right. Okay. So the ones that are left over are just kind of individual ions that don't belong to any one group. So I'll call them the extras. So the first one we have is acetate. Acetate actually has 2 different formulas. I'm going to show you both formulas because I might give you worksheets that use one or the other, and I want to make sure that you can recognize both formulas. When it comes to writing a formula, you can use whichever one you prefer. So probably the one you'll see more often is CH3COO minus. Oops, oh no, no, no. Consistency, come on. Formula first. Okay, that's called acetate. The other formula is just combining the C's, the H's, and the O's together. So this is also sometimes referred to as C2H3O2 minus. So you see that way they just take this C and put them together and they combine those 2 O's. It's the same thing. So I want to make sure both of those are acetate. Okay. So I'll do these individually. And then we have CN. Oh, that's almost an O. Let's not do that. CN minus. This is called cyanide. This is one of 3 polyatomic ions that actually ends with IDE. But here's the thing. If I give you a name, like I say, sodium cyanide, and we'll practice this next week because I don't know if I'll have enough time to actually go through. But if I give you this name, and one of the tricks that I'll teach you is when you're given a name, there's clues to look for, right? So one of the first clues I'm going to talk about is the ending of the second name. If it is IDE, then you want to check it against these polyatomic ions that end with IDE. This is one of them. But even if you forget that rule and you say, okay, IDE means it comes from the periodic table, you're going to have a really tough time finding any element that looks anything like cyan, anything. Like most of the elements end with ium, right? Like helium and beryllium, lithium, things like that. There's no cyanium. And you could spend all day looking at the periodic table. You'll never find anything that looks like cyanide. And so that would tell you like, oh, it comes from that list. I'm just going to call it the flashcards list. Okay, so that's cyanide. And I'll give you the other two that end with IDE as well. And that is OH minus. This is called hydroxide, which is kind of interesting because they put the hydrogen first before the oxygen. And I'm guessing because next year when you take bio with me and I teach you how to translate vocabulary in bio, you almost always translate it backwards. Because again, it's all based on Latin, which nobody speaks anymore. It's considered a dead language. I guess for like super smarty pants that learn Latin for some reason. But a lot of scientific vocabulary is based in Latin. And so we tend to go from right to left. I wonder if Latin was written backwards. I don't think so. Anyway, it doesn't matter. All right, so this is the first one that ends with IDE. This is number 2 that ends with IDE. And the last one that ends with IDE is O2 minus 2, and this is called peroxide. Remember what I said that the prefix per means? I think I erased it now, but up here, even more than. So before, when we were doing binary ionic compounds and the stock system, if you had a formula like FeO or Na2O, the O always represented oxide, right? But now we've added a second oxygen atom, so it's peroxide, like even more oxygen. Peroxide. Those are the three. Those are the three that end with IDE, even though they don't come from the periodic table. And again, with the consistency, I want it to look neat. So let me try that again and do my circle just around that. Okay. And I think there's one more. Make sure. Yep. Last one is MnO4 minus 1, and this is called permanganate. Again, not related to anything else in the list. So they're just kind of the extras, as I call them, but everything else you can kind of put in a group. Well, let me count them and make sure I have them all. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I usually have 27. Ooh. Well, if I think of ones that I'm missing, I guess I'll have to put that in the line group, but that's all the ones. If you look at the PDF, and I'll just show you again. There's a lot more, well, not a lot. There's a few more in this list. Oh my gosh, I know which one I forgot. There's a few more in this list that you don't have to know, like bromate. You don't have to know that one. That one's fine, that one's fine, that one's fine, that one's fine. Oxalate, you don't have to know that one. I'm just trying to give you arsenate. You don't have to know that one. I'm just trying to give you like the major ones. There's also ones that I will give you that are not on this, like phosphite is not here. And again, I forgot ammonium, which is like the only one that's positive. So let's definitely fix that. So of all of them, what color? Let's do light blue. Of all of them, there's only one that's positive. That's NH4 plus, and that's called ammonium. That makes 26. Maybe I do always have 26. I thought it was 27, but I don't know. I guess not. So what I will do is I will send you this note to the line group so you can have that to remember. But what I just want to do now is kind of run through, where is it now? I had a website. Can I see that, please? There we go. So I thought what I would do is, this is Quizlet. I don't know if you guys have ever used it before, but it's a good website that if you just type in a topic here, I just did it like literally, I just Google searched like polyatomic ion Quizlet. But Quizlet's pretty common if you don't know it for having flashcards set up for vocabulary, and I don't even know what else, but I imagine like maybe math stuff as well. I don't know, but so I thought we'd just run through this just to kind of get familiar with formulas and names. And again, if you feel like making flashcards, or I taught this topic to 10B. Oh, no. Sorry, wrong class, because you guys are grade 10 now. Thinking of grade 10 last year, but I'm like, they would be grade 11 now, and that wouldn't matter. Okay. No, your B class, grade 10 right now, we're not at this topic yet because they have to learn a whole bunch of other complicated stuff before we get to this. So anyway, never mind. So just to kind of run through, what does it do? Full screen? Let's do that. Really? That's full screen? That's okay. Anyway, okay, so NH4 again is the only positive one. That's called ammonium. Okay, I guess it's going to tell you how to pronounce it. Right, so here is one of the formulas for acetate, C2H3O2. Another formula is CH3COO minus 1. Oops. Okay, acetate. If you click on it again, nothing happens. I don't know why sometimes it talks to me and sometimes it doesn't. Anyway, you can play around with that if you want. This one you don't have to know. That one you don't have to know. That one you don't have to know. That one you don't have to know. Here we go. Okay. CO3 minus 2 is called carbonate. CrO4 minus 2 is called chromate. ClO3 minus 1, chlorate. ClO2 minus 1, chlorite. Cn minus, cyanide. Cr2O7 minus 2, dichromate. H2PO4. Now, PO4 is, okay, I guess if you highlight it, it talks to you. PO4 is phosphate, and we've got two oh, she's annoying in my ear. I don't think you can hear that, but she's in my ear like H2PO4 minus. H2 makes it dihydrogen, so it's dihydrogen phosphate. And again, it's just a matter of like going over it and over it and over it and over it. However it is that you guys manage to memorize things. HCO3 minus can either be hydrogen carbonate or bicarbonate, either one. HPO4 minus 2 is biphosphate or hydrogen phosphate, okay, either one. HSO4, bisulfate or hydrogen sulfate. So you notice all the ones that have just one H in the front, their prefix can be bi. HSO3 minus, bisulfite, because it's SO3. SO3 is sulfite. No, okay, that one's just wrong, sorry. Nope. OH minus is hydroxide. Don't have to know that one. NO3 minus nitrate. NO2 minus, nitrite. Don't have to know that one. ClO4 minus 1, perchlorate. MnO4 minus, permanganate. O2 minus 2, peroxide. PO4 minus 3, phosphate. SO4 minus 2, sulfate. SO3 minus 2, sulfite. Don't have to know that one. Don't have to know that one. Don't have to know that one. Ta-da! Okay, why this is important. Let me go back to the iPad. Start a new note. All right, why we have to know this. Okay, again, it comes from two sides. Whether I give you the formula for a compound or the name of a formula, either way, I'm going to ask you for whatever the matching formula or name is. So let's just start with a formula, and I'll give you an example of these clues that can help you understand which of the three types of group naming that we have to do. So there's generally a series of questions that I want you to ask when I give you a formula. So let's start with something easy. Okay, so here's a formula. Your very first question should be, is it 2 elements or more than 2? And so you would look at this and you would say there's Na, there's N, and there's O. That is more than 2. If it is more than 2, excuse me, I just finished eating lunch. If it is more than 2, then I want you to think group number 3, flashcards. Okay. And unless the formula starts with NH4, it's going to be the second half that is from the flashcards. So that should then you should be able to break it down into like the metal and then the flashcards. If it is 2, then you have the same question. It's either group 1, which is binary ionic, or group 2, it's stock. And that depends on the second question, which you have to ask yourself in both circumstances, whether it's more than 2 or 2. I'm trying to make this not too complicated, but it's going to end up being complicated anyway. Is the first element a transition metal? I'll say that. Oops. And if your answer is yes, then you have to use 2 stock. The answer is no. Then it's either 1 and or 3. And I just feel like I'm making that really complicated. Okay. Forget the concept map. Give me, let's see, I only see you today because I don't see you Thursday. Give me the rest of the week to come up with a nice, clear concept map for you to follow, because I just don't want to confuse the hell out of you guys right now. So let's just stick to just group 3, which is the flashcard group, right? So you see more than 2 elements there. So you know that part of this formula is going to be from the flashcards. The point of needing to memorize the formulas is that you have to be able to recognize NO3 as being nitrate. Because then all you do is translate the name from that formula, that's nitrate. And again, like we did before, sodium, it only has 1 charge. You don't have to use stock system. So the whole name of this thing is just sodium nitrate. Boom, done. If I give you something like Fe NO3 2, okay? Here, the giant red flag telling you flashcards, flashcards, flashcards should be the bracket, the parentheses, because whatever's inside the parentheses is from the flashcards. And the reason why there's a bracket around it is because you need 2 of the whole thing. So you need 2 nitrates. And in this case, because iron is a transition metal that has more than one charge, you have to use both the stock system and the flashcards. So it's a combination of group 2 and group 3. So again, you just name the first one iron. We know that NO3 is nitrate, but now we have to figure out what is the charge of iron, because if we go, it's still here. If we go to iron, it's either +2 or +3. And let's just be super lazy today because we've had practice with the stock system. If we're looking at this formula and saying, is it 2 or 3? And I look down here and I see a 2. The other thing is, once you learn the formulas and their charges, and you recognize nitrate is NO3 -1, and there's 2 of them, that reinforces that it's iron 2 nitrate. And I know you guys' head is probably exploding at this point, but don't worry, because we're just going to practice a lot. Okay. If I give you a name, let's do calcium phosphite. Okay. The tricks to understanding what kind of compound you're looking at from the name, look at the ending of the second word. If the ending is ITE or ATE, it is 100,000 million gazillion % from the flashcards. So then the only problem is like, what's the formula for phosphite and what's the charge of that ion? Because calcium, you can come straight to the periodic table. You see calcium is in group 2, which means it's +2. So we've got Ca +2. Phosphite. If you go to the periodic table and you're like, oh, that must be phosphorus. No, because that's phosphide. IDE. Just P is phosphide. This is phosphite. So in this case, it's PO3 -3. Now, we're going to do the shortcut way. We're going to take the 2 and put it down here, the 3, put it next to calcium. But it's important to remember, just like in math, if I have x +2 and I want to multiply that whole term, I guess, I don't know what you call that, the whole phrase, whatever mathematical expression. I just don't want 2x and I don't want 2 times 2. I want 2 times x +2. I need brackets, right? It's the same thing applied in chemistry. So I've got Ca and I've got the 3 from PO3. And I've got PO3 and I want 2 of all of PO3. So I got to put a bracket around it, just like in math, and put a 2 on the outside. Okay. If I've got lithium cyanide. Okay, again, first thing, look at the ending of the second word. Now this one does end with IDE. So if the second one does end with IDE, I want you to ask yourself, is it one of these 3 ions? Is it, is it one of these 3? Is it cyanide? Is it hydroxide? Is it peroxide? If it's one of those 3, then that tells you that it's from your flashcards. If not, if it's not one of those 3, then it comes straight from the periodic table, and you just got to take time to figure out where on this side your second element's name is coming from. So cyanide is Cn-. Lithium is over here in group 1, so it's +1. So Li+. Putting them together, it's already equal to 0, so LiCN.